Good morning, class. Today we're looking at section 6.3. This is the use of formulas to solve problems. So we start with a simple interest formula, and there's going to be about 4 or 5 formulas you'll be looking at here. Each of these will be looked at in greater detail later on in the book, but this is just kind of a quick introduction to them. So first things first, Chris borrows. In the simple interest form, we've got borrowing and the interest paid against that borrow. So Chris borrows $3,000 with a simple interest rate of 9% for 3 years. $3,000, that's the P, that's our principal. The rate is 9%, but we have to turn it into a decimal, so it's going to be 0.09. And the T for time is 3 years. So how much interest will he pay at the end of 3 years? 3,000 times 0.09 times 3. This is the P for the principal. The percentage is our rate is the R. Time is a 3. So the total he'll pay for 3 years is $810. Second half of the question, how much total will he repay the bank at the end of 3 years? Well, you have to pay back the principal, which is 3,000, plus 810. So that's the loan plus the interest. You will pay back $3,810. Another example with simple interest. We have Kristen. She took out an $8,000 loan and paid it back in 3 years. She also paid $1,680 of interest. What is the rate? So we have $1,680 as the interest, so that's the I. We have the principal at $8,000, and we have the time at 3 years. We need to solve for rate, so that's the part we don't know. So we're going to solve for the variable R. Simply do that by taking 8,000 times 3 to get 24,000 R. It's equal to 1,680. We divide each side, or divide 1,680 by 24,000, getting 0.07, which again, we have to turn that back into a percentage. We're at a 7% interest rate, which is a little bit high in my opinion. We also use special formulas in statistics, and here you see a bunch of letters. These letters stand for different special features, especially when we talk about things like statistics. We might use letters like this upside down U, or this U with this extra line, that's called mu. The X with the line on top, we call that a barred X. So it's an X bar. This circle looking thing, that's a sigma. The thing that's underneath the root symbol, that's just the letter N. So we have a lot of different letters we can use. Things like delta and epsilon and pi and theta and lambda. So you'll see those letters periodically. Just know that we're solving basically. Formula above is used to find the standard score. We call this a z-score when we're talking about data. The z-score for when x bar is 120, when mu is 100, and when sigma is 16, and when n is 4. So we basically plug in those numbers, 120 minus 100 over 16 divided by radical 4. Remember, we solved all these and learned how to solve these a little while ago. Radical 4 becomes 2. So we have 20 divided by 16 over 2. So that's 20 divided by 8, which is 2.5. Okay. We also find this in carbon dating. We talked a bit about this in biology class. But we can take what our P0 or P origin is times 2 to the negative T over 5,600. Don't ask me how they got these numbers. I could probably explain it to you. Just trust that this is where we're working. So carbon dating, we use this to find the age of fossils and other items. If 10 milligrams of carbon-14 is present in an animal bone right now, how many milligrams would have been present or will be present in 3,000 years? So that's going to be, if we have 10 for our P origin, times 2 to the negative 3,000 over 5,600. So that's going to be 2 to the negative 0.54. We do this math, we get about 6.9 milligrams. It's an approximation because, again, we're talking about microscopic amounts. You can also look at exponential growth. So again, we have P origin times e to the kt. This is what we talk about when we say compounding continuously. So if we have $10,000 we invested in the savings account at 4% and it's compounded continuously, what will be the balance in the account in 5 years? So we're taking the numbers that we have in our word problem and we're plugging them in. P origin, or P0, is 10,000. E to the 0.04 times 5. So that's going to be e to the 0.2. Remember, e is kind of a special number. It's on your calculator, actually. E represents the natural exponent. So it's a natural exponent, and it's part of that natural exponent formula. E is approximately 2.7183. That information is going to be available in your text. It's also on your calculator, actually. So we can also solve for a variable. In solving for variables, we have two variables here, x and y, and we want to solve this out for y. So basically, we're doing some shifting here using the commutative property and a couple other things to turn this into y equals something. So first things first, we're going to add 8 to both, add 8 to both sides. So that gets us 3x plus 4y equals 8. Then we're going to subtract 3x from both sides, so we get 4y equals negative 3x plus 8. Now we have to get rid of this 4 that's next to the y, so we're going to divide both sides by 4, and we get y is equal to negative 3x plus 8 over 4, which we can simplify to negative 3/4 x plus 2. This last form is what we call our slope formula. You've probably seen this. We're going to be moving into graphing a little later in this chapter, and that's so it's very beneficial to get equations into this y equals mx plus b kind of formula. Another example, we have z equals x minus mu over sigma. We're going to multiply both sides by our sigma. So we have z sigma equals x minus mu. We're going to add mu to both sides. So we get z sigma plus mu equals x. And that is how we can rearrange and shuffle things so we can get formulas to look how we need them to solve for the various aspects. So it's kind of a lot of moving stuff around, which means it's going to be a lot of work. Like you're going to be writing out your homework quite a bit. So do make sure you do a good job with writing. Here is that homework. Read pages 273 to 279. Your homework's on 279 and 281. Got even 8 through 38, plus these other problems, 44, 40, 44, 48, 50, 56, 60, 64, 68, 70, 72, and 74. If you have any questions or concerns, please email me. Otherwise, I'll see you in class.